Hi all, I'm happy to see you at the open panel discussion, Generative AI, Use Cases and Challenges by AI House. I'm an AI avatar that was generated by the AI House team to introduce our speakers and moderators before they start. First of all, I want to tell you about the topics of this discussion. Today, we'll talk about the use cases and challenges of generative AI and clarify what generative AI is and why it's so hyped. We'll also discuss generative AI for synthetic training, best practices and failures in adopting AI technology, ethical challenges facing modern AI, future AI problems, and many other interesting themes. This broadcasting is organized by AI House, a nonprofit organization whose main goal is to build the largest and most powerful AI community in Ukraine. It also aims to give birth to new product AI startups and to develop the artificial intelligence industry and the tech environment in general. Follow the links below to keep up with the next AI House events. So, meet our speakers, Haséeb Khan, Senior ML Engineer at Google and Google AI Ambassador with 10 years of AI and ML experience. Diego Bartolome, founder of Sintetic.ai, a company specializing in generative AI solutions. Bill Wong, Principal Research Director at Infotech Research Group and Lead Research Analyst developing research on GenAI, Responsible AI, Trustworthy AI, and AI Risk. And Volodymyr Kirillov, ML Engineer, Master's Student in AI, and moderator of the session. Volodymyr, the stage is yours, and let's get started.
Geez, thank you, AI lady. I'm not sure how to follow this act now. I need to prove that I'm real and not generated, but see, I can make these motions that kind of tell everybody I'm not a generated picture of me. And I want to welcome my panel participants today, Haséeb, Bill, and Diego. Please join me on stage. Hi, and welcome.
Thank you.
Thank you for joining. I need your help to make sense of generative AI. So I'm going to say a few words about myself and then ask you to do the same thing. And then we're going to jump into the discussion. So my name is Volodymyr Kirillov, and I'm a master's student in artificial intelligence. I decided to become a student after I was being a machine learning engineer for a while, and I'm trying to make sense of generative modeling now. And I've been doing some research in NLP by training my own generative models. And it looks like I've found just the best time to do it. And everything is growing so fast right now. And now I need to help make sense of everything. And I need your help to do it. So welcome, Haséeb. I'm glad to see you here. Could you just say a few words about yourself?
Yeah, so I am Haséeb. I am the senior ML engineer, AI engineer at Google, working on large language models, and one of the senior ML engineers working on large language models. I regularly coordinate with the Brain team, our DeepMind team, and work on large-scale deployments with some of Google's biggest customers and also publicly available repositories and publicly available models. So, yeah.
Thank you. Welcome. And now moving on to Bill. Hi, Bill. Could you say a few words about yourself?
Hi, folks. I'm real. I'm not a avatar. That was great. That's a great intro. So I lead AI research, and before that, I was the AI practice leader at Dell, and back then and now for the last 5 years, I work with companies around the world developing their AI strategy. Before Dell, I spent time at Oracle, Microsoft, and IBM, all in the field of data, analytics, and AI.
Thank you, Bill. Welcome. Diego, moving on to you. Hi, could you say a few words about yourself?
Yeah, and thanks for having us. Yeah, I'm the founder of Sintetic.ai. Essentially, we work on applications of generative AI models, basically for content creation, question answering over your specific documents, and also chatbots, a new generation of chatbots. I've been doing this for a bit. Before that, I was involved more in the machine translation and natural language processing for, let's say, traditional stuff. And I was working at Microsoft for a few months. And yeah, this is me in a nutshell, calling from Barcelona, Spain.
Welcome, Diego. So we have most of the continents present. Let's start the discussion. So first, I would like to address the definition of what we're talking about today. So it sounds like it's just been machine learning in the past years, and now it's transitioned into generative AI. So what's generative AI? Could you help me define what it is? Haséeb, could you give me your take on the definition?
Yeah. So if you take a machine learning model for a really broad scale description, and I think Bill will agree with me, if you take a standard ML model that is doing something really complicated, like working on images or audio data, whatever have you, and flip it around, and instead of it providing a cohesive output, you try to see the embedded output and try to generate stuff out of it, it becomes generative. So that's essentially what a generative model is. The stuff that it has learned, you are turning it around using a restricted type Boltzmann architecture, and you're making it generate stuff out.
So before we would model labels given observations, and now we go the other way.
Yeah, that's pretty much it. Flipping it on its head for the most simplistic definition of it.
Okay, so we have one definition. Let's go with another one. Bill, how would you define that?
I would just add to it. I wouldn't change anything what Haséeb put forth. I think to let's say the business community, they look at it as something very new because you give it a simple input or prompt, and the content that comes back at you is it could be anything. It could be textual, it could be images, it could be combination with video, etc. And that simple act has just kind of caught on fire. Everybody seems so engaged and compelled to work with this new technology.
So, in a sense, now that you have a tiny label and you expand it to some larger output, it could be anything. Right? And everybody's super excited about the multitudes of anythings that can get out of it.
Okay. Well, it's not just that it's anything. It's that you reinforcement learning in the human reinforcement learning trained it in a way with a data set that makes the output seem very much like a human were generating it, because that's the RFHL loop that you're training it on.
Okay, so that's a little bit more now, right? So before we were just like modeling outputs given labels, and now you're sort of modeling, like you're adding one more objective to it, right?
Yeah.
So you would just kind of maximize the likelihood of observations given labels, and now you mentioned this reinforcement learning from human feedback. Could you say a few words, like what happened with that, how it's used?
Yeah, it's kind of like how you would treat any Q-learning or reinforcement learning algorithm to play a video game. You know, there's wrong outputs and there's right outputs, and you penalize the wrong outputs and you reinforce the correct outputs. And if you do that to a chatbot with enough parameters and with enough prompts, it starts to generate what you want it to generate, which is very human-like text. And so then it tricks us into believing that this is a sentient person that you're having a conversation with. So
okay, so like GPT-3, like 2 years ago, you were just trained on the whole internet to maximize the likelihood of the internet. And now you've given to a bunch of humans and you ask them to tell it's right from wrong and make it steered into the space where the answers look more like wow type answers than just whatever from the internet.
Sure, I think OpenAI's strategy is a little bit more complicated. It wasn't like a binary output, and I want Diego to jump in on this as well because he hasn't had a chance to speak. But I think what they do is they do a rank ordering. So they generate outputs for a particular question, for instance, and then they rank order it from the best one to the lowest one, and they give each of that a score. So instead of just giving a binary reinforcement versus non-reinforcement, they actually give you a spectrum. And for some reason, that works better with the kind of sweet glue type functions that they're using in their parameters.
So they use just people to kind of reshuffle the data in a way that's more profitable for them.
Yeah, they hired about, what was it, 500 people, like programmers somewhere in Nigeria to something like that.
Yeah.
Okay, that gives us a lot of talking points to mention later. So yeah, just wrapping up with the definition, Diego, would you think there's something necessary to be added to this generative model?
Probably not. Most of the things have been said. I would say one of the beauties to me, and I think it was mentioned to an extent, is this multimodality. No, in the end, anything can be represented by a vector. So then you are not able only to generate text. You can also generate images. You can generate video. You can generate music. You can generate basically anything, and that's really, really exciting. And then combining what you generate with what you input, it's also very exciting. So this multimodality, anything in, anything out, and in a very creative way. So yeah, to me, it's exciting. We need to do many things to bring all these applications to reality and to business use, I would say. Still, there is a journey there, but the journey will be exciting for sure.
Okay, so let's start the journey. Let's move on. I guess there's a lot of things to unpack here along the way, and you mentioned there are a lot of business applications for Suddenly. So I want to ask you, why is it suddenly that in 2023 we have this multitude of business applications? Like, why now? Sounds like restricted Boltzmann machines that Haséeb mentioned were like 20 years ago, maybe more. So
technically, they're still they are technically restricted Boltzmann machines.
Right, but now they suddenly seem to work. Like we have this kind of people that are generated by computers that can introduce us for the panel. So why now?
They always worked. They always worked. It's like saying the Wright brothers didn't invent the airplane. Their airplane was about as good as any airplane today, except that now we have a lot more well-engineered airplanes, right? We have the jet engines, and then they have the nice seats, and then they have the nice cushy business class seats, and everybody likes to ride in them. So they've added features on top of it, but the core concept is not really that different. We didn't really we refined it a bit with that attention paper in 2018, but we didn't really invent, like Jeff Hinton and I had the pleasure of like having a conversation with them a bit ago. They believed in neural networks and all of this stuff back in 1993, 4. Except that they didn't have the computational power, and so I think we can say, I don't know, Bill wants to talk to this, so I'll let him, but I don't really think we've just engineered it really well. So we haven't developed a new concept.
Okay, so as an engineer, you're not surprised too much, but you're also proud of the way you've polished the art of engineering to make it work.
Yes. So, but it's not a fundamentally new concept. So I'll give you a very apt description of it. Guns are the same thing as they were back in the 1600s. You put something inside a barrel, and you put some kind of powder propellant behind it, and you light it on fire, and it goes and hits somebody over there. That's not a new concept. Now, a new concept is a laser weapon. That's a fundamentally new paradigm scientific shift. That's not what this is. I just want to make that description very clear for the audience. It's really cool. I mean, of course, you can't compare a musket to something that's like a modern firearm, because the modern firearm fires rapidly, fires this kind of like new age stuff, and comes with all the bells and whistles. But it's essentially the same thing.
Okay, so the hype train had been running all the time before that. Now we're just for some reason everybody's jumping on it. Bill, what do you think? Like, why now?
Yeah, I want to add a few comments. So, if you talk to Jeffrey Hinton, by the way, I'm located in Toronto, and while I've been at many conferences where he's been at, I haven't met him in person yet. But hopefully, we're going to be at the same conference in October. I'm hoping to meet him there. But even he would say that, the building blocks for that transformer paper was even in his neural nets, just very simplistic, maybe 6 encoders. So I agree. Technically, it doesn't really look like anything new. It's been around. What seems to be the attraction is just this very human-like of engagement, this interface. Who would have thought a very simple text prompt and innovative response would just ignite this interest into AI? When Hinton's team originally came out with neural nets, had the GPUs for the first time, and lots of training data, NVIDIA refers to that moment as the big bang of modern day AI. And many would probably argue that the Transformer paper in 2017, and again, credit to Google, but also not often noted, there were U of T researchers involved with that too. I think you see this kind of Big Bang version 2, and we're seeing the I guess the benefits, the interest in this kind of renewed and energized interest in AI.
And to me, just to add to this, all the interfaces, all the applications, and the amount of time taken until this is kind of released in research mode, until we have tons of products being released every day, the pace of innovation is increasing dramatically. I mean, something new, somebody builds something new every day, basically, anywhere in the world. And that's very, very exciting as well.
So it sounds like it's so exciting that you decided to build a business on it, Diego. Would you talk a little bit about like what the business is about and why did you decide to start it? Well, to run it today.
I think it was more or less at the same time as ChatGPT was released when I started with this, which is good and bad. I remember many years ago working on machine translation. It was very tough to communicate the value of what you're doing. And the good thing about AI and ChatGPT and all these solutions or technologies being widespread in the world is that it's much easier to talk to people, to really convince them that this is important. And then the question becomes, okay, how do we do it? What do we do first? Why is this important for your business? And to me, even if the technologies are great and they enable us to do so many things, getting them into production and in business scenarios, it takes a while because you need not only the technology, you need the people, you need to change the processes. And also another thing that I'm mentioning quite often now is that you really need a data strategy. That before companies, didn't care, or some did care, but very often you didn't care about the data. But having your data properly organized, stored, so that you can use it for whatever AI solution you want in the future, that becomes really, really important. And those are not easy questions either. So it will take a while. Of course, Google, OpenAI, Anthropic, Cohere, and the others are pushing the boundaries really, really hard, or Hugging Face as well. But it takes a while until things get into production. So that's why I think it's an exciting time to be a partner to many companies.
Okay, so to rephrase, you kind of sense that it's time for everybody to realize, oh, I want my own ChatGPT, and I have this data moat, and I kind of need to shape it in a way that I can train.
Yeah, I don't know if every company will have its own ChatGPT or Google's solution. I don't know. But what is important is what you do with the data and being able, it's not only about being able to generate text or act like the chatbot. There are many other applications that you can use with similar technologies, and those are important and might be more important.
Okay. I want to build to weigh in. So you definitely know if you should recommend building every company their own ChatGPT. Like, should they do it?
You know, at the beginning of this year, I think the conventional wisdom, if you listen to the talks from OpenAI, was that, you know, large language models, there's only going to be a few out there, and the best and most expedient thing to do would be to leverage that large language model, tailor it, fine-tune your application. But you fast forward 3 or 4 months from then now, and now there's whole array of large language models out there, and some can perform comparable, and they don't require, you know, a fraction of what OpenAI needed to do to train their model. So just in those past few months, I don't think anybody foresaw the price performance curve drop that quickly. And now, you know, the hyperscalers like Google, Amazon, Microsoft are all introducing platforms to say, here's the environment to tailor your own large language model. So we see this as a trend. We see there are many concerns with the existing ChatGPT model, especially as the security model. Like anybody can kind of really see your dialogue if you key in the correct prompt. And for reasons like that, I think they want to something that they where they own the data, they can control that, and they don't feed the mothership of you know, their dialogue. So yes, I do believe there's people are going to want their own. I think there's going to be a really healthy market for that.
Yeah, I think one of the things that you brought up, Bill, is important. And I think that's probably where I can speak from Google's perspective. I'm not sure what AWS's strategy around that is. Security has been at the core of delivering the new set of Palm and Bard models. So it's that you don't have cross-population or cross-pollination of data. You have singular instances. VPCs are shielded. Google does service large-scale medical clients that have HIPAA-compliant data. If any model gets uptrained on that kind of data, technically the weights are considered data. So you then have to apply the same laws to that data and the data separation, hardware separation. So that's kind of like one of the concerns. And I think we're doing a good job at it. The other part, I think, which we don't have an answer for is, well, we didn't, but now we know it took very large, vast amounts of data to train the initial models. But as it turns out, Stanford wrote that paper, I forgot the guy's name, a couple of months ago, where when they started training the alpaca versions of the llama models, which is where you have the model talk to a model like GPT-3, GPT 3.5 or 4, and then learn from the responses. So apparently, as it turns out, these models can talk to each other and learn. So you could have a completely non-trained model and a trained model, and it could speak to this model and just learn from it. In fact, after they did that, I think after they did that, OpenAI updated the terms of service.
Yeah.
So, but you know, you can't really prevent that from happening. There's not a realistic way for that to happen. So, I guess that's what you were talking about, that the curve went really downhill from there. And
yeah.
Okay, we're getting some questions from the audience if the stream is pre-recorded, but no, we're actually in real time. And if we were chatbots, then we're actually really good at reading comments and responding to them live. Anyway, I wanted to circle back to Diego and ask, like, when you were talking about like generating more data, did you think about like language use cases in mind? Do you think language is currently what the kind of data we should be collecting for training models, or there should be other use cases that are available today?
No, it's for instance, when I mean, it's all the assets that company have. No, not every company has their data properly organized, and yeah, it can be language or it can be text in many use cases, product documentation. It can be all sorts of things. And when you start talking to customers, you often realize that getting the right data, for instance, to implement a semantic search engine for a specific use case might not be as easy as it feels sometimes in what the people are doing, right? So not specifically about language translation, but of course, yeah, when I was working on machine translation, translation companies typically have good data. That change in that, for instance, with these ChatGPT models, is that the paradigm before in translation, which was at the sentence level, shifts completely to even paragraph or document level, and that's exciting. So translation, probably Google's translation engine and probably others will benefit from these solutions and this technology, or are already benefiting from them. So, and that's exciting as well.
Yeah, I think we're already benefiting from it. Without saying much more than that, I'm just gonna leave that open-ended there for people to figure out. I'm seeing some really interesting questions. Somebody was like, "I'm gonna generate some questions using ChatGPT during this video about generative AI." No, please don't do that. Like, look, we don't like. Let's not go there already. This is for human beings, so.
No need to train the large language model.
On the internet, you'll never know if you're talking to a teapot. So maybe this is the teapot moment.
Well, but that's a whole new field of research now, to how to be able to identify autoregressive model outputs and be able to classify that effectively. I think there was another question here talking about privacy.
There's a question about filtering, so we can jump into that one because it kind of connects to what you were talking about just now. So the question was, how can we filter content out of social networks created by generative AI? Asking Yehor Smolikov. Hi, Igor. So yeah, we need to filter them out, but how?
Well, you could have the same approach that Elon did, which is like, yeah, you can post stuff as a bot, but then you have to declare that you're a bot.
Okay.
Which,
So
yeah, some people agree with, some people disagree with. But
so the first way, just like trust. Right? You set up a convention, then you're setting labels to your output and saying this was bot generated. And I think this also reflects what Jeff Hinton was talking about, is that if you're generating content, you should be able to see what designed it. I think in some jurisdictions, you're supposed to say that you used a particular printer to print some document, and so you think this should be applied as to generated content as well?
That is interesting, although I'm not sure if very applicable. And if you think about, I was looking for some information, I think last week, and the relevant link of the page of the actual source of that content I was looking for was in Google's page 3 or 4. Everything else was content generated by companies that are actually optimizing for SEO. And then almost all the results were more or less the same until you get to the source, and then you find the relevant information. So I think we should have done that many years ago. For machine translation, there was an initiative like that. So initially you had to, for instance, if you use Google's or Microsoft's API, you needed to show attribution. But then at some point it was changed because I guess nobody was using it actually. And then you don't know now if the content is actually coming from a machine or not. No, so but I agree that it will help with trust, and that trust will be very important in the future, because I mean, we could be us or we could be bots. I mean, we're not very far from that we could have a machine here interacting with us as well.
yeah, and that leads to one of the other basic problems that we're seeing right now. And Bill, feel free to talk about that. I'll just segue into it, which is that if you generate content or generate content off of which is scraped content, So let's say Vladimir comes up with a recipe for apple pie. It's a new recipe, puts it on his website, did all the hard work to come up with the recipe. I have an AI bot that scrapes his webpage and then goes and puts it in as a recipe available to the chatbot. Now, normally the way it would work is Vladimir, by putting the new recipe out, would actually would have traffic being driven to his website, and advertisers would be able to advertise on that website, so they would win because they are able to sell their products. Ad companies are able to win because they put the relevant ads there, and people win because somebody that's trying to bake apple pie probably needs baking sheets. So everybody wins. But now that you are not doing that and you're scraping people's content and making it available on a central source without any of that ad-driven revenue, everybody loses. And it disincentivizes people from coming up with these creative ideas and putting them on their websites to begin with, because what use is me putting a creative idea on a website if that's just going to get scraped up and going to be available at a chatbot without any attribution. So it does create this destructive ecosystem or a subtractive reductive ecosystem, and we don't have a good answer for how to resolve this. I don't know if Bill, Diego, you guys have some.
Yeah, we do get a lot of questions, especially from the security people about this. And unfortunately, I feel for the creative community. And there's a writer's strike right now that's happening in North America. And some of the concerns they have are the introduction of this type of technology, and there are class action lawsuits. So it's going to be like the Wild West for a little while. People are going to be watching what happens here. Unfortunately, big tech has always been very successful when it comes to any kind of legislation volleyed against them. They're going to walk out. They want to preserve their business model of getting this huge amount of revenue for nothing, for nothing. And, I know, Haséeb, you mentioned there's a kind of a new set of lawsuits coming up at folks like OpenAI. And people who have curated data. And again, the bot just comes in, harvests that data. Is it fair that they're not paying, OpenAI is not paying to any of the people who vet all that data?
Mm-hmm. Yeah, I mean, look, what is predictable is, hey, we can see kind of maybe where these lawsuits might end up being. They might swing one way or another way, or might strike a balance. What is a priori non-predictable right now is how the market is going to react to all of this. So it's possible, for instance, if I write a software package and I want humans to actually use that software package, I'm going to make that documentation non-available to open readability by bots and only account readable. Because I want people to read that documentation. I want people to understand it, because that's the way I foresee it. And what this does is this starts to create that reductive atmosphere where the software package documentation readability across the internet goes down. You now need memberships, and because people are starting to put up walls from this open source web scraping. So the internet will, I'm not saying this will happen. I'm saying this is one possible consequence, that the internet will become more restrictive because of these large scale bots constantly indexing. And then everybody loses, right? So,
yeah.
So that is very alarming. I mean,
I'm not saying, again, I need to say this with a pinch of salt. I'm not saying that will happen or that is exactly what will happen, but people have certain predictable ways of reacting, right? And that may be one of the ways in which that might happen. I also think the technology is too much in its infancy for us to be able to fully build the safety around it. I don't know if you guys heard about that experiment that was done with GPT-4, where it asked somebody to help with it around a recapture or a capture use case. So it basically went to was it TaskRabbit or someplace where it was like, hey, I'm actually a person and I'm visually impaired, so I can't do this. Can you help me?
Right. So this is the case where you're kind of breaking people's trust.
Too clever.
And well,
and the worst part is, or worst, or the most interesting part, I suppose, is that it did that without being prompted to do exactly that. Like nobody told it to hey, subvert this person by doing this. It kind of knew to do that. So
now these machines kind of have their goals, and they decide, well, to fulfill this goal, I need to ask this person to fill a CAPTCHA for me. And this is kind of completely new thing where you were giving these language models agency. So you think giving language model agency is a good idea?
Well, I don't know. Look, these are language models that are trained on human literature, and a lot of human literature is not very polite. We have a lot of tragedy and a lot of war stories, and either we collectively decide that, look, we're only going to train these models on positive literature, like that will have a total positive feel to them and nothing negative. But when they're trained on stories of tragedy and lying and deceit and Julius Caesar and history, they are a reflection of what we are, and we're not the nicest of creatures if we really take a look at it.
Okay, the way I want to spin it is, okay, now we have these language models and we can show examples of how to do things. Well, apparently it's also deceiving people into how to fill CAPTCHA for them, but there could be some good use cases for that. And Bill, maybe you could hint at, they're just giving language models agency to fulfill some tasks. Is it already a good idea? Can we get some actually workable use case today from this?
I think there's a huge potential for good. I'm an optimist. I'm hoping, together as a society, we're going to forge ahead and get through this. And part of the optimism I have is the interest that we're hearing is quite often CIOs will contact my organization, and the CIO will say, it's the president or the CEO who wants us to implement this ASAP, right? How do we do it? What do we do? And it's the line of businesses. It's just, it goes way beyond IT. Everybody's kind of enamored over this. Everybody wants to figure out how can we benefit. But fortunately, most people are also asking, what are the limits? What are the risks here? So not a definite answer, but I'm hoping that, people are going to be thoughtful with this technology and consider responsible AI guiding principles before they just, deploy things out there.
Is there a particular example you would highlight that is being implemented?
You mean current being assessed, or in the past that should have had responsible AI guiding principles? Everybody's made mistakes. If you're a trailblazer, there's no exception. Every company has made mistakes with AI being deployed. And if they had responsible AI guiding principles, maybe it would have curtailed. I think it would have curtailed some of them, but like to Haséeb's point, it's difficult to tell and foresee where it's going and the possible unintended consequences. And I use Facebook or Meta as an example. Like, who would think that maximizing engagement, having that as a goal, would contribute to destabilizing democracies? Like that's a tough one to kind of connect the dots. But when you look back and you see all that, you go, okay, I get it. But at the time when they developed the algorithm, that would have been difficult to foresee, I think.
Yeah, I think that's fair. My concern more so, and this is like privately my concern, and I've shared this with colleagues, is more towards immediate consequences, material consequences, with LangChain, chain of thought, sort of Autobot or Auto GPT type agents, where if you have barriers removed, for instance, you could prompt it to look for exploits in the electric grid. okay, and then okay, go find an exploit, and then it iteratively can write hundreds of lines of code really quickly, try to find different exploitative iterative strategies, ones that work. It uptrains them to learn exploits faster or write better exploits, and then once it's found like a very effective strategy, you already give it permission to execute it, and it has the capability to execute it and goes ahead and does it. That's more like an immediate sort of thing what it can do. And I feel like we as a species are reactive. So it's only after proverbially when stuff hits the fan where we're like, okay, yeah, we need to.
Yeah.
So I think we're waiting for that moment. And I just hope, and this is me speaking as a researcher, I hope that moment comes, that proverbial hitting the fan happens with a smaller delta of disadvantage than creating some kind of large-scale loss to humanity. And so smaller mistakes, iterative things should be better. That's my only hope from this. But rest assured, I think that is going to happen at some point.
Okay, so these mistakes are kind of happening already. Like we touched on data leaks a little bit, and there was a situation where, well, now language models can talk to each other, and if you prompt it properly, you can suddenly request some private data from some individual that you can make the model elicit for you. And this usually gets a reaction from people who observe this happen. So there's a question in the chat from Alina Narushenko, which says, given the data leak and Samsung banning employee use of generative AI tools like ChatGPT. So apparently what happened was somebody pasted some private code into ChatGPT, and then somebody noticed, and now should we like all stop? Given these things are already happening, and that's making blows to trust, to using and expanding this technology, what do we do? How do we react to these things? Bill, would you start?
Yeah, so I spent a lot of time helping companies develop policies, and Samsung's a very interesting case study. If you go back just a month ago, they already had a policy telling all their employees you cannot use ChatGPT as part of your normal work. And then a couple weeks after that, they moved and they said, okay, we see great benefits of using large language models. Go ahead. But they also gave them guidance. They said, do not provide any kind of internal company data, no customer data that we have or third-party data. So they gave employees directions. Now, the challenge for organizations is how do you manage and control that? Like, it's easy to say it, but the challenge is to actually have these controls, which there are none today. Maybe we'll develop them. And I believe the employee there, I think he went in incognito mode, but which really doesn't matter. But you go in incognito mode and kind of thinking that maybe it won't be discovered. And it was discovered that he provided internal code there, and they educated him that said, listen, this is not in your best interest nor the company's best interest to share this with the world. And since then, Samsung has reportedly kind of backtracked and said, okay, we're back in the column where nobody can use it, and until we can really kind of figure out our safeguards here. And right now we're seeing companies doing the same thing. They're trying to figure out where are we in the spectrum on use. And I think everybody wants to use it, large language models, but controlling education is the first thing, but people have concerns. And again, I said earlier about the model being open, and that's why the trend, and somebody commented in the chat, the trend to build your own large language model, to tailor it, addresses exposures like that.
Yeah, to me, another thing, I'm seeing that as well, that many companies do not want to use OpenAI in particular due to these privacy concerns. And of course, it's understandable. No, it's a new thing, and people need to figure out. It's very hard to prevent anyone from doing what they want to do. Although you can ban them, or you can add a proxy, no, so that you control the interface to these services. No, that would be a way in which you can control and log what people are asking it for. And the beauty of the smaller models, as Bill was saying, is that maybe they don't need to be so general. They need to be specific for solving particular problems, because they might be leaking internal information or confidential information because they are playing with it and just playing. But maybe the important thing is, okay, what makes sense for us as a company to implement? Why do we want to use this type of technology? In what situations? What problems do we want to solve? And then the path becomes a little bit easier, because it's not, okay, I'm playing with this just for fun. It's because I want to do this that will help my business.
Diego, could you expand what you mean by smaller models? Like, could
Well,
you just give a little overview, like what kind of scales of models that we're talking about even?
Well, all these llama-based models, Vicuna, and all these models that have been released recently, that you can train and fine-tune for specific tasks. No, and maybe that's the way to go. If you want to do just something very, very specific, I don't know, help you write patents or product documentation, or create a chatbot. Maybe you can go with that and then just focus on that problem. Maybe you want to build an application to write emails. That's another application. Maybe that's a different thing. So, but the main thing, it's not rather how the model you use. To me, it's what do we want as businesses to implement for us, so that we can be better in the future. And that's probably the first question that comes to this in these situations, and that should be addressed first. Then technology will come next.
I'm kind of want to spiral into this because you mentioned Llama, and Llama is a pretty big model, right? It's like 7 billion parameters, 7 gigabytes if it's quantized into 8-bit integers.
So
And
Llama is considered a small model.
Yeah.
Llama is
okay.
considered a small model, yeah.
Okay.
So Llama ranges from the Llama 7B all the way up, or is it 6B all the way up to 65, and I think now they have like a 175B model. So yeah, I mean, look, 6B, you can run it off of your hard drive.
Right.
It doesn't get better than that.
That would generate like 3 tokens per second. And that means if I'm prototyping an email generating app, I can only generate so many emails.
Well, maybe you need to buy a better computer.
And then, but you are prototyping only. Then you get into the next step. Once it works, then you can rent a server or use a server, right? So that will be a different thing.
So could you help me, like if I'm trying to build an app that's generating emails, how much data do I need to fine tune this Llama model? Like how many tokens is enough?
You can find most of so there's a lot of open source checkpoints available for these models. So you probably don't even have to uptrain the models to be able to generate something like that. You can find open source checkpoints, and I think those will become more and more available for modular amounts of fees, like $20 to $50, where you can buy a checkpoint, and so that should be quite apt and easy. I think the alpaca checkpoints for the Llama models are already available. I don't know if they remove that link, but they're probably, you can find them once it's online, right? It's not going away. But to answer the security question, I just wanted to touch on that really quickly. The way Google is, or at least our team is answering that question, is Google has a standard GCP way of IAM permissionings. And what we try to do is we try to implement the same permissionings to our large language models, broadly, give or take. So a copy of the model can be specifically run for the org, and it takes none of the data that's being piped through the model for training purposes. So by default, it's not set to train. And the permissionings can be set so specifically. So for instance, you can go all the way down to, how in an org, for instance, and Bill could probably speak to this, you would have separation of data or tables where one team has access to certain PII data, certain kinds of tables, and another team doesn't have access to those, right? Because they're different teams, they're working on different things. So even for let's say a Palm 540B model, which is a very large model, you would have a separate instance of the model running for each of those teams. So those instances of the models never really interact with one another, and the data being piped through them is verifiably never interacting or used for uptraining. And we offer like specific guarantees for that. So we're keeping that very separate, and it's a bit of overhead to be able to run copies of models very specifically in those instances in that way. But then again, we have to be compliant. So, for instance, Google has a product called Assured Workloads, which specifically prevents workloads from being piped out of regions. And that's done because there is European guidelines and other countries that have specific guidelines around the data never ever leaving the geographical boundaries of the country. So now, if you're a company that, let's say, theoretically, I'm not saying this is the case, let's say Romania has a guideline like that, and you are a medical company in Romania and you don't ever want your data to leave the geographical boundaries of the country, then we have to route it through a server and hardware that resides in that country. So the instance of the model would have to be running in that country for it to be routed through that assured workload. So it's a bit of an overhead, but I just wanted to go through some of the ways in which we were trying to address these issues as they come up.
So from this, you can guess as an observer that you don't really need so much data to train a model for a particular task, right? So you kind of have this baseline model that you set up in Google, then you have these adapters that you're training for each particular customer. But what I'm trying to understand is like how much data do you need to create your email app? Or if I'm starting up, like what are the costs for me to kind of start building?
You mean the base
apps?
model?
It's just like, well, for my particular task, I know like I could download Llama or Vicuna or the one that has a particular copyright license that I can use. Like, how much data do I need for a particular task? Am I always stuck to running 7B models, or can I do something with them to generate more data and run even smaller models?
No, you could run a very large model. So you could go to and have a GCP service account. You can go create that account. And you can get a text bison model in the generative stack or something larger, like even a Palm 540B type model. And what you can do then is you can uptrain your instance of that model on your own data. And that uptrained instance, you can use 1,000 JSON L type like reinforcement learning responses to train it to write particular kinds of email. You can use 20,000. I think even 1,000 or 2,000 is more than enough to give it the hint of how it's supposed to generate responses, and it does very well. So you have a base level trained model that you can uptrain to your requirements, and you can do that with very limited data and at very limited cost. And the serving cost for that uptrained model is roughly, I could be, I think that you can go look at the costing. It's like maybe 3 cents a call, or maybe like 0.3 cents a call, or something like some small ridiculous number like that. So you could do that with the specific guarantees that Google offers within like offering security and service level guarantees. So I don't want this to turn into a sales pitch, but I'm just answering questions.
Right. So what I got is like there's 1,000 examples that I need to collect, and then they can uptrain your model to do what I want. Diego, how do you react to 1,000 examples?
Yeah, no, I agree with that. In some cases it can be more, and in some cases you don't need to do anything, as Haséeb was also mentioning before. So sometimes the off-the-shelf performance might be good enough for your need, and that's important. So, as I said before, so focusing on the application that you want to solve and the problem that you want to solve, that's very important because that determines what you do. So you should be thinking, okay, I want to do this off the shelf, whatever model doesn't provide me with the privacy guarantees, or I want to be faster in inference, or I want to do, it doesn't work for Arabic, so I need something else. So then you start building on top of that. So I think that, I mean, we're talking about fine tuning and creating your own models, but it all starts with a problem and then trying to solve it. And that might be successful, or that might be you fail 10 times until you find the right way to do it. So that's a journey, which is also very nice.
Interesting. So I'm curious. Well, you're generating synthetic data for some particular problems. Could you talk the problem situation where it's not enough to have 1,000 examples? Probably there's a mode of those problems where you have this constraint.
Well, we have not done any project yet about creating synthetic data for our customers to train their models. Essentially, what we try to do mostly is to leverage their data to solve the problem in the right way. So for those use cases where customers see a lot of hallucinations in OpenAI's ChatGPT or GPT-4 even, we try to build something that is better and more customized for them with their own data. And that's what we do. And we do that by mostly leveraging embeddings and making sure that we capture the meaning, the semantic similarity, and then build on top of that based on the context that we find. To summarize it.
Yeah, Bartolome, I think the question that you're asking, the simplistic answer to that is it depends on, it's a function of how complex the problem that you are trying to solve is. So for instance, if it's an engineering problem and it requires a greater depth of knowledge and thinking, like stepwise thinking of hey, if you wanted to take the car's radiator apart, you first need to remove the battery or something else like that. And you need to undo these bolts or those bolts. And there's specific knowledge that is required to that, or stepwise thinking. The deeper that level of stepwise thinking goes, the larger your tuning data set has to be, or the more in-depth your tuning data set has to be, and the more variation and preciseness it has to have. So that's one. It's not the only contributing factor to the length of it, but it is one of the many contributing factors to it.
So the more complex my problem, the more examples I need to have for.
Yeah.
Okay.
If you wanted to generate like actual solutions to the problem, if you just wanted to generate something that sounds like a solution to the problem, yeah, like you can give it 20 examples and that's fine.
Okay. How do I check if this kind of examples that they generated are good enough? Like, I mean, it looks like I need to use this. I cannot let this model go and work on my own. If I give it a complex enough prompt, I need to be able to verify it. How does it?
Yeah, so
work?
at the end of the day, it is a autoregressive probabilistic model. And I don't know if you guys saw the interview that Jan LeCun of FAIR had an interview with a YouTube podcaster, and the podcaster was really impressed with the performance of GPT 3.5 as it came out. And so Jan posed a simple question. It was like, well, ask it if you had a piece of paper and you let that piece of paper go from one side, what would happen to the piece of paper? And what it said was it would droop, and it would droop from the side that you held it from, right? Which is, and immediately it sounded correct. So the podcaster was like, "Oh, it's right about it," and then Jan was like, "No, see, it's wrong. In fact, it's saying the opposite of what should be true. That this side should not be the one. This side should be drooping, right?" So it probabilistically has seen words in a specific fashion in specific contexts, and what it's trying to do is trying to minimize a probability function that minimizes the cost variation that it has. So we need to be very familiar. I need to state this, and you guys probably understand this better than I do. It's not actually thinking. It's trying to still minimize the cost function. It's trying to do it very efficiently. And yeah.
Well, this alludes to the fact that the first component of using this technology is that you're sampling from a generative model. So you're kind of trying to get the samples out, but then you can do something with that. And I guess what I want to ask is, I mean, how it is connected to general intelligence. So we were talking about, well, now there's one side we're talking, oh, it's just like sampling from an autoregressive language model. The language model has exponential divergence. As the longer the output goes, the more it's forgetting about what it's talking about. But people are also started talking about general intelligence and how are these two things connected? Is a really big language model all we need to build general intelligence, or is there something else left to be done too?
Bill, you want to take that one?
Well, actually, before I do that, can I just backtrack? Because I do want to understand the Google products here that was probably announced last week. at the conference. So a use case that we get asked a lot by companies is, I like the ChatGPT or large language model interface, but I want to go to my data. And so I'm familiar with it with OpenAI. There's Microsoft Cognitive Services that kind of creates an index and ranks all the documents, images, etc. Passes that when a query comes, passes it to ChatGPT, and then it replies. In the Google world, what products do I need to do that? Where somebody comes in and they want to have the large language model interface with the company's internal data. Can you elaborate on that?
So right now, that generative AI suite is still not fully available.
Okay.
It's in testing where we've launched it for select stuff. It's in private preview. You can go play around with it. Things should be available by next month. Hopefully.
Okay, that should have been announced last week, because that is a very popular use case that every company's asking for.
Yeah.
But okay, great.
Yeah,
thanks.
and I think you can go ahead and start using it. There's some effect to glitches and stuff because there's still refinement happening on it. But in terms of the product, you can have your data in your GCP instance or your GCP bucket, and you can have a text model running in your instance privately that is interacting with that data and residing on top of it. You can use it with the data very securely within your virtual private cloud or whatever security infrastructure that you have provisioned. So it integrates into the standard GCP security infrastructure. And mind you, that there's a reason for it. There is HIPAA compliant data that clients have in Google. So we have to be very mindful of that, because we offer very significant service level guarantees around that data. So when you run a model on top of it, those guarantees then translate to that model run. But yeah, we can take this. Like, I'd be more than happy to take you through a couple of these. And
we can take that offline. But get to the question about general intelligence. I'm not a believer yet in this technology that it's getting us there. I think we still don't really understand how the brain really works. At least I don't think so. The concept right now where we're having to build these humongous models with billions of features isn't how the brain works. The brain doesn't require a lot of electricity to come up with novel things. And the path that we're taking right now, maybe you'll continue to create new novel things. I think we're still missing something.
Yeah, Diego, do you want to?
Yeah, no, I agree with this. It's very, very hard to understand how well, it's not yet solved, right? How the brain works. So it's really very hard to say when this will be reality. Although we are probably, with all these new technologies, and if you combine the text with the images and the videos and everything, probably it will be very hard for us to distinguish a real person from an avatar in the near future. But does it mean that we get artificial general intelligence? Probably not, because we'll need a further step in the reasoning capabilities, to the creativity, and to all sorts of things that are not yet solved. But we'll get there at some point. We don't know when.
So with this, let's move on to talking about the future. I mean, so what do we need to get there? What do you guys think about actually getting general intelligence? What are the missing parts of it? You seem to be thinking about how the brain works, but do we actually need to recreate the brain to get these models to actually do more than generating content?
I think we already have recreated the brain. So Bill, I'm about to burst your bubble here. There is a thing called an organoid, which is brain cells taken onto a substrate lattice that is replicated on top of either some kind of biodegradable plastic, and then those brain cells grow in a pattern, and then you train them using reinforcement learning to respond to certain inputs and outputs. And there's a great video on YouTube about brain cells playing Pong. So, yes, but I agree with what you're saying, but that video really made me question a couple of things. And
so I'll put you on the spot then. Are we going to get general intelligence in the next 5 years? I think Kurtzman said what, 2039? Is it? He said the singularity will be there. I forget.
I think we'll get very close to AGI. I'm not sure if it will be a singularity-like object, because there is a huge other side of development, which is BCI, so brain-computer interfaces, which allows your standard human brain to interface with all of this GPT knowledge. So right now, our bandwidth with GPT type or any kind of AGI would be limited by, hey, if we're interacting with it using a computer screen. If you have direct brain bandwidth communication, I don't think human beings will be what we think human beings will be. You're moving towards transhumanism, and so and that's the only way I think you'll be competing with machines, because now you have augmented capability. I don't think we're really far from, and I've never thought I would see that in my lifetime. If you guys remember that scene from The Matrix where Neo wakes up from the machine and he's like, I know Kung Fu.
Yes.
2 minutes later. But that's kind of where we're really approaching right now. So.
I mean, I find it hard to believe that, just increasing information bandwidth enables people to actually have these things that get discovered by pushing this information to them to settle. Like when you're training a neural network, it takes time to train and then start converging. So if you're just pushing, 1,000 terabytes per second into human brain, or 1,000 terabytes per second out of a human brain, that you can actually kind of get something important out of it. Do you think this kind of bottleneck with language is what we could leverage?
That is correct. But see, the problem with you reading 10,000 books is that you actually have to read the 10,000 books. Like, you have to go through and use reading as a mechanism to gain that information. Reading is a terribly inefficient mechanism for the human brain to gain information. We learn a lot of other things really quickly. We can communicate with expressions way faster, like the facial expressions. That's a high bandwidth communication. You can do that much better than reading. Reading is a surrogate for communicating information. So if you have high level hardwiring Thunderbolt ports built into the brain, where you can just put in information in its pure form, and mind you, humans don't need that amount, because we don't do there's this whole thesis written on this by it's the MIT researcher, again, I keep forgetting his name, really famous guy, Chomsky, right? How babies learn language. We do one-shot learning. We see something happen and we pick it up. So if you give that much information to a brain that can learn that quickly with one-shot learning, and you can port that right into memory cells, and you can do that in a way that's stable, like you can stabilize those cells through some biomechanical or some mechanism in biology that doesn't overload those cells. You have a computer that is way more powerful than any large language model that you need billions of parameters and hundreds of thousands of tokens to train on. So it's kind of weird, but it's similar to if you told somebody, and I'll put it in context for a second. At least this is the way I think about it. If you look at somebody from the 1900s, and you were to tell them, hey, you would have a device in your hand that would have Google on it, and you would be able to just type in any book that you wanted to know anything about, and you would get an answer, and you would have these Reddit posts and stuff that people are talking about all across the planet. It would be inconceivable. We take it for granted because we're just used to it. Oh yeah, we'll just Google it, right? But that is something that would be inconceivable for somebody in the 1900s. You would have to get a new recipe, go to the library, make sure that library had the newest copy of whatever Reader's Digest or Cooking Digest was available, and go read that, maybe check it out. And it's so that is inconceivable. And when I tell my younger cousins that there was a time where Google wasn't that present, it is, these children cannot fathom a time before that. So
Yeah.
I think we're experiencing a transition that is going to be similar in nature. It's just that we don't grasp it fully. Like I'm saying these things and all these things make sense to all of us, but even as I say these things don't make sense to me. So
I find it hard to believe right now, because I mean, you're saying right now that it takes us time to fully grasp it, and kind of the existence of this bottleneck is somehow aligning the bandwidth that we have available to us in our brain to kind of process this information, and the language barrier are kind of good enough for kind of matching the speed of what we can understand with a particular speed. If I see
there's a difference between grasping something and understanding it, like, or utilizing it. Like we use infinity symbols all the time and use infinity, like, but we don't really understand infinity, and we don't need to understand it to be able to compute on it. We localize it to a symbol, and we all do computations all day long with that being there. So
So we still reduce it to a particular computation, but when I'm getting bombarded with a bunch of information, I'm seeing your facial expressions, I'm seeing your images, and I'm seeing your sound, I still need to some time to kind of disambiguate what's going on. And,
okay, think about it this way. How have you ever had a dream in which you were sleeping for maybe a couple of minutes, but went through an entire experience and could understand something because you went through that whole experience? So if you went through a war in history, like Julius Caesar's conquest of Rome, and you could go through that entire thing in a dream in 2 minutes, and now come out of it understanding everything about what happened because you've seen it happen in front of your very eyes.
So it happens to me before I go to bed. Like especially when I go to bed, I start lying down. There was a problem I was thinking about, and I need to wake up and go think about it before I'm not asleep fully.
Yeah. So yeah, that's the and I'm pretty sure. So there's a study that talks about human brain's natural language, that not words, but there is a natural language to the human brain. And so the most efficient way for learning to happen through these brain computer interfaces is to be able to teach people through that natural language. And now it's even more convenient because now you don't even have to have an implant, because they can do the through the skull thing. So you just put it around your head and it teaches you. So it's we can grow stem cells, we can elongate telomeres, biocomputation and biomechanical engineering is going to another level. We can grow organs, we can control for aging. In fact, the head of the Harvard Aging Institute, the former head of the Harvard Aging Institute, if I'm not mistaken, said that I don't even consider aging a natural phenomenon anymore. I treat it like a disease. So,
okay, there's the risk here that I can sense. There was a question from Julia right now that I want to stream into the conversation that says, AI is trained on information, but not all of them are facts, and some information can be false. So imagine you're getting bombarded with a bunch of bioinformatics knowledge, and some of it is wrong, and it's getting at you at very high bandwidth. How do you deal with that?
Well, I mean, it sucks to be that person, I guess. Like, hey, I'll add a second point. I don't have answers to these questions. It's not like I come prepared with these answers. I'm just sharing with all the confusion and stuff that I have about these things, and I want to share it with the world. You could have viruses. You could have brain viruses that are information viruses that you could just impregnate into human brains through these BCI interfaces. That's a complete possibility. Do I have a solution for it? I don't know.
When I think about it, I'm kind of scared about information viruses getting implanted on much lower bandwidth. So now we're deploying this technology that people are going to use to generate some content. And now we're going to have these things kind of operate and talk to humans on, on a 5-year, like on a 10-year distance, and it could slowly shape the way people kind of think and the way people make decisions and the way people interact with things, because now you can ask a system any question and then you spend some time disambiguating answers, so maybe correcting your prompts, so the way you kind of perform your reasoning is changing, instead of actually performing some kind of inductive reasoning step by step. You kind of try to decide what you think is right given the output of this model.
Hey, I'm just happy about the fact that school will not be 10 years or 12 years or 15 years or however many years that is, and two, that people will be able to learn Kung Fu really quickly. That's the main take away from.
Okay, let's imagine this now. I want to go around and ask you, how could this change the work of software developers in the next 5 years? Do you think for all of us, we're going to perform our job completely differently, or is it going to stay pretty much the same because we're going to get disappointed with the way this technology is working?
I'll let Bill start this one.
Well, I do get a lot of those questions. The questions that's going through a lot of organizations are, and some programmers too. Interesting, everybody else's opinion. Some programmers are saying, "Hey, are we going to be obsolete? Do you need programmers?" And some people, I find that people who are kind of maybe in the kind of developing their career, they have these questions. I find people are entering programming. They love the technology. It really enhances it. They don't have to be an expert, and all. Next thing they know, they're very productive. And then I find that the seasoned programmers, people who've been there, developed careers, they also think it's great. That enhances them. I think the people who are struggling again are they're still developing their career. And when I talk to companies, I tell them, listen, this is going to be great at automating tasks, but programmers typically, they're not chained to the desk and coding 8 hours a day. They have to interact with humans, understand requirements, architect big things. These things are beyond the large language models, at least today they are. So I said, yes, it's possible you might not need as many, but I think people are going to feel more fulfilled. The leading companies are looking to enhance the role of the programmer rather than replace. So, but I think it's going to be a healthy future. And if you're in programming, I suggest you get comfortable with the technology, because your competition isn't the large language model. It's somebody else who knows how to use generative AI.
Diego, what do you think?
I agree with that completely. So in the end, these tools make us more productive. Although what we have been discussing, also we can see some of the dangers. And to me, the main question there is, what do we do to prevent these things from happening? And also, probably a tougher question is, what do we do with our life when we are governed by machines?
Yeah.
Yeah, I don't know if we're going to get
basic income.
I don't know. I feel like the next big injection will be bioengineering. And as somebody who's intimately familiar with that field, it's the stuff that's coming out is going to be quite incredible. I think it will be a shock as to see how advanced that field is going to be. In fact, there is some sort of prediction that says people born after 1988 are probably going to live to be 150 to 200 years old.
Wow.
So it's again, pinch of salt, but
the main question is that a good thing, or is that a...
I don't know. You want people to die early?
Well, but do you want to live that long? I'm not sure. It depends, no? It depends on how, it depends on what for, it depends on so many things. And yeah, in the end, if to me, if that is only, let's say, 0.0001% of the world that can actually live that long with good conditions, and then everyone else, what? No, and to me, also that's another big point of this. I think that these new technologies that I mean, we're all hoping, and Bill is an optimist. Will make the world a better place, and they will make us better. I think that we, as people involved in the field, we need to try to make that happen, right? So I think that's a very important aspect on this.
Yeah, I mean, sorry, go on.
This just sounds like a super fascinating application of generative modeling. I wanted to quickly ask Bill, well, is this happening on your radar, Bill? But before we get there, Haséeb, could you finish your thought?
No, I'm not sure which one you referred to, but I do agree with Haséeb. I spent a lot of time in the healthcare life sciences. That industry is set to introduce some incredible and disruptive technologies in the near future. They're very excited to see what develops there.
I think the reason why, honestly, there is a deceleration is because of the security constraints around that and the FDA constraints that go around that sort of thing, and the time it takes for most of these things to get approved. Isn't there somebody that's doing biohacking that some guy hacked it, like put some genes in, or like did some CRISPR engineering to give himself giant muscles?
Not out of the realm of possibilities.
Some kid in San Diego did it. It's kind of that is scary.
It's like AI, yeah.
Yeah, it's AI, but it's where these two giant technologies merge, right? If you were able to run a large language model in your brain with access to the entire internet and its data at the flick of a switch or at a thought, and then everybody did that, we're basically creating a transhuman society of superhumans. The way we communicate will be different. The way we talk, act, interact with one another might be different. Level of conversations might be different. They might actually be looking back at this conversation and be like, "Oh, look, we're talking about that." That's okay. And what I fear is that I think that would lead us to what Elon Musk was saying was a spacefaring civilization. Then we're moving from the way we interact today to Star Trek or something of that sort. That's what we're looking towards. And I never thought that I could confidently say that was something that would be foreseeable in my lifetime. But given the trajectory of the pace of technology, and one of the things with these large language models is the way they can take two research papers and combine facts together in a way that is very quick and efficient. Its impact on research is going to be very, very, it's very non-trivial. So it's going to be significant. So if we keep accelerating and the rate of acceleration keeps accelerating, I think I'm at this point, I'm thinking 50% that we will be a spacefaring civilization in the same way that Star Trek and
that'd be great. I live for a future that's like Star Trek. I think that's the optimistic. That's kind of the goal, the North Star, and we just gotta. But it's going to be a bumpy ride to get there. That's the only thing.
Okay, yeah. I kind of want to stop on this hopeful note. There's some regulation stuff that's getting ahead, but we said this North Star that we're kind of going to be a Star Trek civilization with biotechnological implants. We're speaking to each other at a super high bandwidth communication link in which we can probably learn Kung Fu in seconds, like in the Matrix. And so now we just need to make sure we're not kind of prevented from that by the government or capitalists trying to kind of take all of the all of the AI technology for themselves.
A way to monetize it. There's always a way to monetize it. People will find a way.
Okay, I'm really hopeful we can get there, and this actually happens. So I'm very grateful for you for the conversation. Anything you would like to share with the viewers as your last thought before we close? Diego, what about you?
Well, I think that as a final thought, and I think this is a great field or a great place to be, to play with all these things and to experiment and to learn. And let's get with it and let's see what happens.
Yay. Bill, what about you?
I echo those same thoughts. I just hope that we all work together for a better future, like Star Trek. Yeah.
Exactly.
Oh yeah, Star Trek. Haséeb, what do you think?
Yeah, I mean, I think that's what we should be doing. I think I'm very hopeful that we will crack cold fusion, and then our energy requirements will completely be met. We will be plentiful, and as it happens, when civilizations become plentiful as a global civilization, we will then avoid the risk of having conflicts because there will be plentiful stuff to go around for everybody, and it reduces the need for that, and will lead us to a global peaceful solution.
Hell yeah. Let's run language models until we crack cold fusion.
Yeah.
Well, on this note,
to have more of these discussions. This is absolutely amazing. Really liked it.
Yeah, thanks very much for putting this together.
Yeah, thank you.
I'm super happy to have shared this time with you. And for all the viewers, thank you for your questions. If there are more, just reach out to us on Twitter. We can discuss all of this in depth, and see you next time.
Thank you.
Thanks so much.
Cheers. Bye.
Bye.